Wavelets aren't as scary as they look. I wish more people used them. Compression, level of detail, and cache friendliness. That last quality is, I think, the most interesting for me personally. The problem is most math about this makes it very unapproachable, talking about Fibonacci and the sort of base understanding, but really we're just talking about averages and differences. The Haar transform is the simplest wavelet to understand. You can take a list of numbers, you group them into pairs, and then you compute the averages and differences. The nice thing about this is that you can reconstruct the original perfectly and the number of numbers hasn't changed. You've just reorganized the data. The cool thing is you can go deeper with this. You can keep on doing it until you have one number that is the average for all, and then you can go down to the finest level of detail. The code connection for this is really whether or not you want to filter by the size of the list or the threshold. So maybe you had a list of 5,000 items and you want to get it down to 500. Alternatively, maybe you had a list of 5,000 items, but you only wanted to throw away the stuff where the detail didn't matter. It didn't cross some kind of threshold. And then you get an indeterminate size, but you know that it's a predictable quality of detail. Finally, depth packing and spatial order are really interesting. Generally, when you're on the CPU or you want to sort of scan through the whole list, you want to sort of do the depth order. However, on the GPU, or in a case where you want to query a specific part of data, especially if it's like 2D data or 3D data, you usually want some kind of spatial order and layout for it. Finally, the big picture is wavelets are just the general average and then some detailed bits, and they map beautifully to hierarchical structures like quad trees and octrees and various other lots you can come across. They're also just the introduction. There's a bunch of other things you can do, from edge detection, and there's a bunch of other transforms you can do, a lot of compression, a lot of sound and stuff, but there are also some interesting domain-specific stuff, which is why I think it's useful general knowledge for devs to have. And that's it, really. It's really simple math that unlocks a big power. And I hope this helps you understand wavelets a little bit more, or at least some interest in exploring them.